In the last lesson, we looked at matrices. What you may have noticed is that matrices are two-dimensional objects by definition, as they have rows and columns. However, there are specific cases of matrices which are also widely used. One of them is overwhelmingly common: a matrix with one row and one column. Naturally, it contains a single element. That's called a scalar. In fact, all numbers we know from algebra are referred to as scalars in linear algebra. For instance, the number 15 is a scalar. So are 1, 2, -5, pi, and so on. Since scalars are objects with no dimensions, they have important properties we are going to examine later on. For now, we just need to introduce the basic terminology in order to be able to dive into linear algebraic operations. All right. Next on our list are vectors. Vectors are also very common objects in linear algebra. They sit somewhere between scalars and matrices as they have one dimension. Here's a vector with three elements: 5, -2, and 4. Notice that this vector is nothing more than a 3x1 matrix. Its single dimension is the number of rows it has. Since a scalar is basically a number, a vector is practically the simplest linear algebraic object. Due to the many applications of vectors, they have this special name and are often examined as a separate object. Moreover, it is more common to view a matrix as a collection of vectors, rather than a vector as a special case of a matrix. Okay. Generally, there are two types of vectors: row vectors and column vectors. We just explored a column vector. Logically, we can have row vectors like this one: 3, 4, 5, 8. Often, we are interested in the number of elements a vector contains. We refer to that number as the length of the vector. The first vector we saw had a length of 3, while the second one, a length of 4. Okay, great! In the general case, a vector's length can be designated as m. So, a column vector would have dimensions m by 1, and a row vector 1 by m. Regarding the notation, the elements of a vector x would be x1, x2, until xm. Let's summarize. We have matrices that have two dimensions, m by n. Vectors that have a single dimension, m by 1. And scalars that have no dimensions and are 1 by 1. In the consequent lectures, we will learn how to add, subtract, and multiply matrices, vectors, and scalars, which will make these concepts even more intuitive. Thanks for watching.